So we will start with reactions in organic chemistry. Let's start with alkanes. Alkanes are those functional groups which comprise of carbon-carbon single bond. Carbon can make 4 bonds, and in alkanes a carbon is making 4 sigma bonds, which makes them saturated hydrocarbons. And because they are saturated, they are also unreactive. Alkanes undergo combustion. Combustion is burning in oxygen. It can be of 2 types. It can be complete. Complete combustion takes place when there is excess oxygen, and in this the hydrocarbon burns to give carbon dioxide and water as products. For example, methane, it's an alkane. When this burns in oxygen, it will give carbon dioxide and water. Combustion can also be of another type, that is incomplete. An incomplete combustion may be due to limited oxygen. In this case, not all the hydrocarbon will burn to form carbon dioxide and water. Some might, and hence you will have carbon dioxide and water as products, but some of the hydrocarbon may just burn partially to give us carbon monoxide, and some may just give carbon, which is called soot. Alkenes can also undergo combustion, and hence combustion is not a very specific reaction for alkanes. Another reaction alkanes can undergo is cracking. Cracking is the process by which large useless hydrocarbons are broken down into smaller useful hydrocarbons. It's of 2 types, thermal and catalytic. Thermal, as the name implies, occurs under high temperatures, for example 450 to 700 degrees Celsius. It also requires very high pressure, up to 70 to 100 atmospheres. And under these conditions, large hydrocarbons, which are very useless, are broken down into smaller, useful, much more useful hydrocarbons. Another type of cracking is catalytic, in which we require a catalyst, which are called zeolites, which contain aluminosilicate. Some amounts of temperature and pressure is also required here, but not as high as those required for thermal cracking. You require up to 400 to 450 degrees Celsius temperature and a few atmosphere pressure. An example of cracking would be, let's take C15H32, a very large useless hydrocarbon, breaks down thermally or catalytically to give useful hydrocarbons. For example, it can be any combination. Let's take ethene, let's take propene, and let's take octane. So this is octane. This is ethene, which can be used to make polyethylene, which can be used for plastic bags. This is propene, which can be used to make polypropene. And this is octane, which can be used for fuels. This right here was very useless, and it's broken down or cracked to form very useful organic compounds.